Again, welcome to today's session. We will be talking about professional data management. Really, we plan to look at how data summaries have evolved to the point where all of these principles and practices that we typically preach in our webinars basically have become kind of a must-have in research. Then we'll look at the different features and functions of ARM that really promote and enable this idea across an organization. And really with the hope of the key takeaway being that just small steps at specific key phases of a research season can really unlock huge gains in productivity and efficiency, with ARM kind of being at the core of that. All right, so let's begin with really a look at the end goal with the research being data summaries. Once you've gotten all of the data back, the most rudimentary approach to this would be just sitting down to a stack of papers and manually reading and reviewing all of the information that's been documented for a few trials. The advantage, I guess, to this approach would be you really don't need hardly any prior thought beforehand, right? Don't need really any preparation time, just have the trialist have at it, follow what needs to be done for the experiment, collect all the data in any way, shape, or form, and hand it over to me. And then the researcher can look and parse through that to learn and understand what took place. Of course, the downside is that really maximizes the time in the chair trying to summarize that information. And usually you'll have the added bonus of having a deadline breathing down your neck as you're trying to make sense of all this information. So, I mean, it's possible you could look through that stack of papers. I went to NVU, doesn't sound much fun, but from just a practical standpoint, I can't imagine being able to look at and compile mentally more than a few locations that you would run an experiment at before it's just too much even to process and look through. So obviously that's pretty impractical, pretty much like working in the Stone Age. So any real group, of course, would be using computers, some sort of software program to store and process your data. That's pretty much a given. That's going to obviously speed up the calculations you can do and the analysis that can be run, which allows the researcher to draw conclusions quicker, present your findings in visual ways. There's just obviously so much more that can be done once you get a computer involved. So pretty big jump, of course, from the first approach that your increased bandwidth for processing information, allows a research program to grow. It can do a lot more than just a couple of trials before losing your mind. And of course, as an ARM user, you know firsthand why ARM is the best software for this job. It really allows for communicating instructions and results for this complicated research in a very structured way with a common vocabulary, and that's really critical for efficiency and accuracy in research. However, there are still challenges to work through with this. Computers are very literal. So although a researcher can instantly understand that untreated check is the same thing as UTC, people have slight variations in their treatment list, or that percent control is the same as CONTRO in the rating type, a computer thinks those are totally different. They don't literally match, so clearly they're different things. So, even with all of that structure and vocabulary that ARM offers, here there's an example how you can end up with, three different ways that the exact same assessment, the very same thing you go out and do, you can describe it different ways, even in ARM. And the problem being, we can see each of those and know instantly that those are like the same thing. A computer is not going to do that. When you go to summarize, it's thinking those are totally different data sets, different things that shouldn't be combined. So you have that problem to deal with. A lot of the other pain points that people experience actually kind of all can be traced back to communication. Were the protocol instructions followed? Did the trialist provide all the information that the sponsor had required? Was the information entered consistently by all the trialists so that we can summarize and we don't have this example from before of different descriptions for the same thing? So all of these issues create a new bottleneck. You're, spending all this time sending emails to request missing details. You have to go in and fix trial identifiers and other administrative errors in those trials. You have to calculate or convert data to get them all into the same units of measurement. All of these things have to happen before the summarization process can even begin. And all of this only worsens as the requirements across the industry grow. For example, tracking the environmental conditions, your weather and things like that, more important than ever. Drones, if you have to have a drone flight, there's just a dizzying number of parameters and calculations that you get back to sort through and what of this matters and what doesn't. The amount of information that needs to be documented is just growing more and more. And so it's only making these problems that are kind of already inherently things to struggle and work through, just magnifying those. So wanting to grow, expand, survive that mess, I suppose, to grow, you could just add more researchers. Each of them get to deal with those same headaches of that inconsistent formatting, missing information. But hey, at least we have a larger volume of trials that can be run for an organization. That'd be one approach. I think a better approach that we would advocate for is let's actually address and minimize those bottlenecks to become more efficient in summarizing data. And that really is the goal of our trying to give this a terminology, give this a name, professional data management. So let's kind of try to define some principles that would guide this idea here. The first would be to, the first is communicating the plan for an experiment. So all the requirements and the expectations for the trialist. A lengthy Word document doesn't have the structure to clearly communicate the requirements, and it definitely doesn't allow for consistent data collection when you want that data returned in a consistent, structured manner. The second pillar would be on-site data entry and review. Using digital tools is really the best way for consistent documentation and avoiding any, transcription process that, of course, can be error-prone. Next is quality control. Enforcing your business rules and validating that all of the recorded data is accurate to ensure that everything, all the required information is documented. And finally, securely storing and transferring all of this information and, abiding by any regulatory requirements along the way. Those are all important as well. So ARM, it's more than just a tool for storing data. It really is the solution for implementing these ideas of professional data management. A complete ARM protocol really communicates the requirements for the experiment, but in a structured way. It provides the template for all of the trials in the experiment. Our EDC, the Electronic Data Collector add-in, that connects trial information to the data collection apps and seamlessly imports the data back into your trials. So eliminating the human touching of transferring, trying to eliminate any of those potential errors, making it seamless as possible. Study rules in ARM trials, that really enhances the baseline validation function that ARM offers, which of course just enables the communication and enforcement of those business rules and requirements just on the ground right in the trial. And finally, sending an ARM trial is secure because ARM, all ARM files are encrypted. Also, on the regulatory side, things like GLP, GEP with the audit trail, all of those are fully supported with ARM. All right, so taking a step back, how does this all fit into kind of the larger picture with ARM? Kind of like that, the evolution of the data summaries. There's this evolution to the use of ARM within a group. So the first phase would just be to really digitize your research data by just implementing ARM, going from pen and paper or from Excel into the ARM software. That really opens the door for communicating instructions and your results for this complicated research. Being able to have that in a structured way with that common vocabulary, it's critical for your accuracy and your efficiency in recording all that information from the research. The second phase is really the focus today. It's then moving forward into leveraging all the standardization features of ARM to optimize the research data for computer summaries. Then the final phase would be your summarization and analysis. If you skip phase 2, then this third phase is really expensive. It costs time and effort at the busiest time of year, like we had outlined in the evolution of all of the problems that go into just getting the data and then trying to summarize all the pitfalls and problems with that. By bringing in these standardization features, trying to maximize your ARM trials, then your data is ready for multi-trial analysis. And it can be integrated into dashboards and other downstream tools using the ARM trial database, which really can automate the summarization efforts. You make really nice standard reports and different visualizations like that. There's just a whole world that gets opened up once you get information into a database, into that structured, consistent format. And so, the reason for all of this is that your time is valuable. If we can reduce the amount of time that is spent chasing down those missing details and cleaning up trial files, that leaves more time for the good stuff that adds value. Having more time to analyze and present the results leads to better decision making as an organization. At the end of the day, that's what research is all about: making decisions, not making busy work. And this also leaves more time to improve for next season. Maybe now we have the bandwidth to try out digital note taking or tackle some of those dusty items that have been on the to-do list forever. So how do we achieve this professional data management? A lot of it comes back to protocols, actually. If taking all of those pain points from the data summary evolution, so many of them were tied to communication. And an ARM protocol really is the ultimate starting point for communication. It sets the template for all of the trials in the experiment. So let's look at some of the specific functions that really advance this idea. You can use the trial location table in a protocol to plan out the administrative details for each location or each person responsible for trials. This is the starting point for creating trials, and it seeds them with the important but unique information like your trial ID. And you can actually link each of those records to a specific ARM licensee or a company so that the full list of trials isn't visible to the trialists, only the trials that are assigned to them. So that way, someone doesn't know everyone that you're working with. If it's kind of a contracted research situation, you maybe don't need each individual to know who all you're doing business with. So that's a nice advantage to allow for that communication, but also natively kind of limit what gets put out there in the world. Next would be study rules. And that is all about, enhancing the validation capabilities of ARM to suit your specific research requirements and your business rules. If you've been in our sessions before on rules or validation, there's very, very limited, not a lot that happens by default with that validation because ARM doesn't know what research you're doing. So creating those rules feeds information to ARM to know what to check, what information is required. Of course, the advantage, if you put those into a protocol, then that distributes those rules to all of the trials that get created from that protocol. And so then that way, that validation process can occur at the trialist level. You don't have to wait to get the data back for you to run and check and see what is there and what isn't. The expectation can move to the trialist. As the data gets put in, ARM can run those business rules and provide immediate feedback. Oh, this is missing. This needs to be put in, etc. And third would be standard evaluations, or SEs. And those are just templates for describing assessments. So distributing those will, instruct the trialist on what ratings to perform, and most importantly, creates consistency in how that trial data is entered. So summaries, of course, will go a whole lot smoother with those in place. Don't have the measurement switching. Oh, they used this unit when we wanted this unit. or even just that small tweak in the percent control versus CONTRO that you can get when people enter and describe those assessments their own way, right? So, this effort all starts with the protocol, but really you seal the deal by enforcing those tools when you receive data back from the trialists. Many times we hear comments to the effect of, even though we rolled out some rules or we use some of these features, we're still getting trials back with the wrong trial ID, or it doesn't pass validation, or they didn't use our assessment descriptions. And so it's really important to enforce the use of those tools. It's not too much to ask for the trialists to use your protocol. Don't they didn't create their own from scratch. Use the protocol I sent you to run validation. We provided SEs. You need to use those to fill in the data. So, the the approach I recommend when responding to any pushback that the trialists try to give with these functions, these things that you would add to your protocol. You really just let's count up the time it takes to process a trial that is not conforming to these requirements, that's not using these functions. The time it takes to fix those assessment headers, to email back and forth to get the missing data, the missing information, all of that should be added up. Then multiply that by how much your position makes per hour. That's how much that trialist has cost your company. And so just scribbling those numbers down, I think really highlights what the whole point of this effort is. Just maybe you throw out the idea of maybe this is the amount that should be deducted from the payment for the trial. And suddenly, hey, maybe there'll be more understanding. It'll make more sense that the change is good. Using some of these functions is important because in the end, not using these tools is just wasting your time. Might be quote unquote easier for the trialists because they just do things the way they always have. I don't have to learn to hit validate. I don't have to learn how to load an SE. Oh, that's easier. Well, it's costing us money. It's costing us effort. It's costing us time. So we need you to do this. And in all likelihood, big picture, the way the industry is, one company implementing these might not be the only company that they're working with. And so it's not a one-to-one relationship either in that concept of, oh, it's effort for me. You as a sponsor are making me work harder, making me do all these extra things. In all likelihood, there's other sponsors sending them protocols with the same functions. So pretty quickly, some of those excuses, I think, fall apart. And just comes down to time, right? It just comes down to that effort and time, and not taking advantage of these efficiencies is wasting time. Okay, all right, off my soapbox. One more set of features here that would also contribute to professional data management would be, harmonizing your ARM use across your company. These aren't quite as high impact as the protocol writing, but they do help promote consistency across the researchers in your organization. Things like creating a product dictionary to standardize how treatments are entered. That can be really helpful, especially for groups that test a lot of different products or different formulations. Having everything in one dictionary that everyone has can be useful. You can also sync other lists in ARM as well. If you build up the contacts list or really anything that you're doing in using in ARM, all of those personalizations like editor views or report sets, things like that. You can even, create templates for protocols that really can help kind of establish SOPs across your protocol writers. This is what we do in an herbicide study. These are kind of the very basics. Let's create a template for when we want to write a protocol for that type of study. We have a starting point. It's got our standard language for the various protocol instructions. It's got this and that from your protocols, being able to seed your protocols and have a template for the protocols, which are your templates for trials, just kind of more and more layers of standardization, right? So where do we start? The key I think is you can really start small. You don't have to do all of these things, and they don't have to be perfect the first time. Just setting up a dozen study rules and getting them into all of your protocols, and just making that list of trial IDs ahead of time. That's like a perfectly reasonable start for the first season, right? Um, it's because these efforts really can snowball. You do a little bit, try it out, then those time savings you can really leverage next season. So once the data starts coming back next season, and you'll see these benefits and save some time, then you can reinvest that time into expanding that rule list. And maybe now we'll put together some SEs as well, because we have more time the next year. And you also kind of learn kind of what works and what doesn't, as far as, we put this rule in and it caused problems, or, oh, instead of making it required, let's just make it recommended because there was these couple of oddball situations that popped up where it didn't make sense, or things like that. Or, oh, it turns out we still had to ask for this, that, and that from everybody this year. Those are more rules we should add. So there's definitely kind of an iterative process to all of this anyway, since you're really trying to match up the rules and the functions to what your research is. And of course, the research is always churning and maybe changing a little bit as well. So just you kind of get that immediate feedback as the trials are progressing and you're getting data back. That's feedback for these standardization functions. What can we do different? What can we do better in that list of rules? In the, oh man, we need SEs because this year I'm just getting hammered with how much I have to be messing around with the assessment descriptions or whatever. So knowing that you can start small and it will snowball. It's already an iterative nature. Just getting your foot in the door is pretty big. My last point would be something called the Pareto principle, which states that 80% of your outcomes result from 20% of efforts or actions. Basically, it's not a one-to-one ratio of time and productivity. An hour spent cleaning up a single trial is not nearly as impactful as an hour writing study rules that'll guide all of next year's trials. So, making a commitment to, this idea of professional data management, of implementing some of these features and standardizations, that'll really make a real difference next season and beyond. So all that effort, work really hard because data's coming in and there's so much to do, doesn't necessarily mean that effort, all that time, you could spend a lot less of that time invested now instead. I kind of try to imagine just stealing a couple hours in the future next year when things are really, really tough. If I could just steal a few hours of that and put it in right now, boy, that's great. And even if it was a 1-to-1 ratio, that'd be helpful. If I could save me 3 hours of work when all the trials are coming in and everything's crazy and a mess, if I could use just blow 3 hours now when it's not so busy, that'd be cool. And it's even larger than that. It's not a 1-to-1 ratio. 3 hours today could save literally days, as you just look at some of these functions and what they can provide. So that's it. That's the idea, at least. If you have questions, if you need help, just starting the process, where do we go? Let us know. We're not here just for the technical question of how do I install this program, or there's some weird error. We really do try to be a resource for the industry. We get to see all the pain points and problems everyone has, and that collective, I think, is pretty powerful. We try to tune the ARM software to address those fixes, or those problems by creating fixes. But that's kind of the overall goal with some of these presentations as well, just to tie everything together. So surprising, I've got time. Most of these sessions, I blab the entire hour, but whether you have questions right now or it makes more sense if you want to schedule a call to just be able to talk through what your group is struggling with, and we can kind of match up. I rambled through a lot of functions, and it doesn't mean every group needs to do every one of those functions. It might be just 1-2 small things that would really make a big difference to address the specific pain points that your group has. So definitely reach out to us. We can play doctor, if you will, to hear the problems and try to prescribe, here's a function, here's something you could implement to kind of fix that there. I do have a question in the chat. The ARM database is very useful. Sometimes we need to use local summaries. I'm not familiar with that term. Any plan to include Parquet files as an output? I'm not familiar with that term, what type of file that is. I can do some research to understand what that might be. If that's is that just like a file format that then you could turn into another system?
Yeah, Javier here speaking.
Yes.
Yeah, so the Parquet file is a relatively flat file, or is a
Okay.
file type similar to CSV files. But it admits to have some hierarchies stored in there. So you can have like a flat files, but they contain hierarchy inside. So they are very good for analytics because they can be read as they are columnar stores. So you can run summaries, let's say with Power BI, an example, just running on the top of those files directly. And they have some other advantages like schema drift protection and other features that are very good for analytics that go beyond of flat files like TXT or CSV. So that will be really a great adding to RAM to be able to generate a multi-trial summary with Parquet file as an output, and you could run a Power BI summary on the top of that file much more reliably than with the current CSV output that you get with the RENST example.
Okay. Yeah, very interesting. Like I said, I don't know offhand, and me not knowing what it was is probably an indication. I don't think we're on the cusp of having that function, but definitely intriguing. I'll kind of pass that along especially to the programmers who probably would understand it better than I would, to know whether that's an option. I think in general, just to flesh out the differences, a flat file versus the database. In general, we promote the database because of how much information is in a particular trial, right? This is, pretty complicated research typically is what ARM is being used for. So as the requirements, the desires to include various metadata in addition to just the flat,
Exactly.
assessments. That's the
Exactly.
challenge, right? Is if
Exactly.
just
Yeah.
assessment means, hey, that would be easy. Throw those in a CSV and send them on their way. Cool. There's a lot more involved that you might want to include, and the what we have currently is the trial database
Mm,
where all of those fields in an ARM trial get flattened out into an SQL database where
mm,
then you can hook up a dashboard, hook up a statistical tool, something like R or SAS can connect to an SQL database and extract information. So that's what we have currently, but definitely the idea of a Parquet file, we'll do some investigation, see if that's a realistic option for things moving forward.
Excellent. Thank you.
Appreciate the suggestion and the idea. Like we said, we're trying to serve the industry. So if the industry is moving a direction like that, we want to hear about and find out what we can do to support that. So great question. Awesome. Well, again, I guess that's all I've got here. One more question about security came in. Yeah, kind of, and we did tie in a little bit to the webinar last week where we talked about the product list. So the example here, if a product is coded, but the essential information of the product is input into the product list, will that get shared with the CRO? So great question. I don't think I have any visualizations, but we'll just look at the slide when we brought in that product dictionary idea. And that is a really good question because I probably should have addressed that better in last week's session when we were talking about that idea. So the product dictionary can include some sort of confidential information. I think that's what you mean with the product is coded. Maybe it's the name you don't want to release or formulation details, whatever, right? Um, and for your organization, of course, you'd want all of those details available. Everyone should know what this product is and the details of it. But if we're contracting those trials out, certainly that CRO only should have certain details, that coded name, maybe none of the formulation or none of the ingredients at least, things like that. So the product dictionary is actually a very good way to achieve what you've described because your organization controls who can, who has access to that dictionary. And then the trials, you can fill in the details, and you would, of course, want those coded names. And, something like the ingredients um, aren't saved in the treatment list in a trial. They only are looked up from with that product dictionary. So that way, in my own company, we can look at those products, we can see the dictionary and know everything about it. But when we send that trial on, only the details that were visible in the treatments editor, that coded name, maybe the formulation's blank, or the formulation's there, but there's no ingredients. Just what's on the treatment editor, that's what's visible to the CRO. They don't have the dictionary, so their ARM only goes off of what's in the editor. And that really provides that security level. They can still operate the trial. You include the product rate, they can calculate product amounts, perform those applications. They can do everything they need to do, send the data back. And now internally, that dictionary you have completes the picture, right? And you can do your summaries and whatnot. maintain that confidentiality. So really great question, and a good note for myself on last week's webinar where we talked through that scenario. That'd be a really good explanation to include in there as well. Great questions. All right, not seeing any other ones. I guess we will give everyone 15 minutes back in their day. Appreciate you all joining. I think this will probably do it as far as the webinar series goes. This will probably do it for the year. We'll pick back up in, can't really say the spring here in the Northern Hemisphere, pick back up in the spring, but pick back up in a few months anyways, once we get through the end of the year season. So thanks everyone for your time today and the excellent questions. And we'll be talking to you again soon.